this video, we're going to discuss describing motion using a function. And for this, we need to understand a couple of very basic things. We need to understand that the position function is given by s of t. Well, the velocity, by definition, is the rate of change of position. So the v of t function is the derivative of s of t. And the acceleration is the rate of change of velocity. So the a of t is the derivative of v of t, or the second derivative of s of t. So we're going to use this knowledge to answer all of the questions in this example. First question is, what are the initial position, velocity, and acceleration of the particle? So let's get the velocity function by taking a simple power rule derivative here. So this is going to be 3t cubed over 3 minus 10t squared, 10t, this is 3t squared over 3, sorry, 10t over 2 plus 6, which simplifies to t squared minus 5t plus 6. And the acceleration function would be the derivative of that, which would be 2t minus 5. So when we look for the initial position, velocity, and acceleration of the particle, initial means at time t equals 0. So all we have to do here is take the s of 0, which is going to be 3, the v of 0, which is 6, and the a of 0, which is negative 5. So this is our answer to question A. Question B, what are the position, velocity, and acceleration of the particle at time t equals 2? It's not all that different. All we're going to do now is just sub in 2 instead of 0. What we get is 8/3 minus, this is going to be 20 over 2, so 10, plus 12 and 3, that's 15. So we get is 5 plus 8 over 3. Simplify that by changing the 5 to 15 over 3 plus 8 over 3, we get 23 over 3. And then we'll do the v of 2. That's going to be, take the v of t function, sub in the 2. 2 squared minus 5 times 2 plus 6. We get 4 minus 10 plus 6. And we actually get 0 at that time. This will play an important role later on in this question. And then we have the a of t, for which we'll also sub in 2. What we get is 2 times 2 minus 5, which is negative 1. So we've gotten through part A and part B, and these two are relatively easy. The next question is, for what intervals of time is the particle moving forward or right? And then part D, we're going to answer at the same time. The question is, for what intervals of time is the particle moving backward or left? And we're also going to address part E at this time, which is at what times is the particle standing still? Well, if the particle is moving forward or right, that means that the velocity is positive. If it's moving backwards or left, velocity is negative. If the particle is standing still, that means the velocity is 0. So we actually already have one of our answers here. We already know that at time t equals 2, the velocity is going to be 0. but we need to find all of the answers. So what we're going to do here is we're going to do the first derivative test. So for part C, we're going to take the v of t function, which is t squared minus 5t plus 6. And then we're going to set that equal to 0 and solve this by factoring. T minus 3, t minus 2 is equal to 0. So that means that at time t equals 3 and t equals 2, the velocity is 0 at those times. So to solve our parts C, D, and E, what we're going to do is we're going to plot our velocity on a number line and determine where it's positive or negative. So at time t equals 2 and at time t equals 3, we know that the velocity is 0. So what we can do is we can test numbers. Let's test 1 here in each of these intervals in the velocity function. So the easiest way to do this, since we're not really all that interested in whether what the actual values are, we're just interested in whether it's positive or negative, is actually to take this version of the function. So 1 minus 3, 1 minus 2, well, this is going to be negative and negative. When we multiply two negatives, we get a positive. That means the velocity is positive on this interval. 2.5 minus 3 is negative. 2.5 minus 2 is positive. So what that means is that when we multiply those, we get a negative. So the velocity is negative on this interval. I'm going to put in 3.5. This is going to be positive. This will also be positive. Multiply those out and we get a positive. So that means that the velocity will be positive on that interval. So part C, let's not lose sight of our question here. For what intervals of time is the particle moving forward or right? That's when the velocity is positive. So it's moving forward or right on these two intervals. So the first one there is going to be here 3 to infinity. Now for the other interval here, we actually don't need to go all the way to negative infinity because remember we're dealing with time. So we could say from 0 to 2. So in reality, this isn't really a left arrow. This should really be 0. Okay. Whether you draw it that way or not doesn't really matter. Just make sure that we put the answer down that way. Part D, the particle is moving backward or left on the interval where the velocity is negative, so 2 to 3. And part E asked us when the velocity was, when the particle was standing still, which was when v equals 0. So the particle is standing still at t equals 2 and t equals 3. So now we're going to pick up with part F, which is for what intervals of time is the particle accelerating forward or to the right? And this again is relatively straightforward. That's when the acceleration is positive. It's accelerating backward or to the left when the acceleration is negative. And it's not accelerating, well, when the acceleration is 0. So we're going to do the same exact steps, except now we're going to do them for the acceleration function. The acceleration function, a of t, we had figured out was 2t minus 5. Now what we're going to do is we're just going to go ahead and plot that. Now this one you actually don't even necessarily need to factor anything here. Just set that equal to 0. and 2t is equal to 5, and t is equal to 5 over 2, or 2.5. And then we're going to go ahead and plot that on our number line. The a of t, again, this really is 0. It wouldn't be necessarily, you wouldn't lose points for putting the left arrow there, but it just doesn't make sense because remember, we're solving for time here. This is 2.5. We're going to test some values. We're going to test 1. We're going to test 3. So we're going to sub this back into the acceleration function. 2 times 1 minus 5 is going to be negative 3. It's a negative. And I don't really care about this value. I just want to know whether it's positive or negative. And 2 times 3 minus 5 is 1, and that's positive. So on this interval from 2.5 to infinity, the acceleration is positive, and on this interval from 0 to 2.5, it's negative. So I'm going to solve it just the same way we did before. Part F, it's accelerating forward or right on the interval 2.5 to infinity. Part G asks us when we are accelerating backward or left. That's from 0 to 2.5. And part H asks us when we are not accelerating. That's when acceleration is equal to 0, and that's at time 2.5 seconds. So we've got 2 more parts to this question. The total displacement of the particle on the interval 0 to 10. Now this is relatively easy. Displacement is the change in position. So let's address that first. Change in position is just final position minus initial position. So on the interval 0 to 10, all we have to do for part I is do the position at 10 minus the position at 0. So let's copy our original function here. T cubed over 3 minus 5t squared over 2. And then it's plus 6t plus 3. So the S of 10 is 10 cubed over 3 minus 5 10 squared over 2 plus 6 10 plus 3. So we get 1000 over 3 minus 500 over 2 plus 63. And if we want to simplify this for decimals here, this is 333.3 repeating minus 250 plus 63. And this all works out to 146.3 repeating. Now we could truncate that to just 146.3. The S of 0 we got in the very first step. It was the position at 0, and that's over here. That's 3. So that means that the change in position, let's call it delta S, from 0 to 10 is just 146.3 minus 3, which is 143.3. Part J is a little bit more complicated. It's asking us for the total distance the particle has traveled on the interval 0 to 10. Now, to understand why this is more difficult, you have to understand the difference between distance and displacement. So let's consider what happens at time t equals 0. At t equals 0, we know our initial position of this particle is at 3. And then we know that this particle is going to move right from 0 to 2.5, to 2 seconds. So the particle moves right from 0 to 2.5 seconds. Excuse me again, from 0 to 2 seconds. Then going back to our velocity in part C, this time part D, it moves backward or left on the interval 2 to 3, and then from 3 onward it moves right again. Now we're not really interested in infinity, we're really interested in 10. So for our purposes it's really 3 to 10. So the way this particle is actually going to move is it's going to move to the right, then at time t equals 2, it's going to turn around and move left, and we don't know how far, I'm just showing you a visual, and then it's going to turn around, and until t equals 10, it's going to move to the right again. Now, we already know where it's going to be at t equals 10. At t equals 10, the position is going to be 146.3. We just solved for that. But what we need to know is this position and this position in order to determine exactly how far this particle travels. Well, to do that, we will take the s of 2 and the s of 3. The s of 2 we conveniently already have. That's 23 over 3 that we have found in part B. The s of 3 we'll have to solve for. So we'll do 3 cubed over 3 minus 5, 3 squared over 2 plus 6 times 3 plus 3. So we get 27 over 3 minus, this is going to be 945 over 2 plus 18 and 3, that's 21. And again, just to get this into somewhat easier decimal forms here, this is going to be 9, this is going to be 22.5, and this is going to be 21. So what we end up with here is 7.5. So we now know that at t equals 2, we're at 23 over 3, and let's get this into a decimal form as well. This is going to be 7.66 repeating. So at t equals 2, the position is 7.66. So from time t equals 0 to time t equals 2, we have traveled from 3 to 7.66. So on the interval 0 to 2, we have traveled up to 7.66 from an initial position of 3. So in that interval, we have traveled 4.66, a distance of 4.66. From 2 to 3, we're going to travel from 7.66 to this point, which is 7.5. Okay? But of course, we're not interested in negative. We just want the distance. So it's 0.16. There is such a thing as negative displacement. There's no such thing as negative distance. And then from 3 to 10, we're going to travel from this 7.5 position all the way up to the SF10, which we had previously solved as 146.3. So that's going to be 138.8. And then we're going to add these three distances to get our final distance. So the distance is the sum of those three, because it is the total distance traveled in that time. This is 4.82. We get is 143.62. Thank you for watching. If you found that helpful, subscribe to our channel. We have many other videos up, and we'll be continuously posting throughout the year. If you have anything you'd like us to post, feel free to email us and check out our other videos to see if there's something in there that might be helpful to you. Thank you.